Oi, sorry, Mark. Wow. Look at that. So tonight it's Ramadan, and we see this quite a strange sight of a star. Oh, there goes the mosque. I'm just going to get this focused there, like that. I don't know if this is what the Muslims look out for. Let's just bring the exposure down a little bit. Okay, bringing the exposure down. What do we have here? I'm zoomed in as much as I can at the moment, but this is this is visible to the naked eye. You can basically see this quite bright. I'll try and get it to about the brightness that we can see it with the eyes right now. This is about how it looks to the eyes. So noticed this about 15 minutes ago, and so the star was kind of emerging from, it appeared stuck to the moon at the time, but now it's getting further apart. So yeah, I'm presuming this is part of what the Muslims look for, or how they mark the start of Ramadan. So you can see, I'm not sure how much you can see, but I'm basically, okay, I'm zooming out now. I'm just looking at this from my front garden, peering through a gap in the trees. There is a power line in the way there as well, I'm afraid. That's basically what I'm seeing. Pretty cool, huh? Let's get the exposure down a little bit more. Gives us a little bit more definition. I'll bring it down, right down, see what happens there. Okay, that's making it disappear now. I'll put it on auto. That's what we get on auto. Okay. So just for the record, this is from Phuket. It's March the 24th. It's about 8 o'clock in the evening. And also the start of Ramadan. It's alright, you won't get in it. Alright, cool stuff, huh? So as this time of year is actually quite significant for cultures all over the earth because of the changes we see in the seasons, it's the beginning of spring or a new year in many cultures, especially those that follow a lunar calendar. Let's have a look at what we're actually seeing in the sky from different locations. So we'll compare the data that we can see here for the moon rising and setting in Phuket with Bristol in the UK, because it's my home for one thing, and it's further up north in the so-called Northern Hemisphere. Now, let's be clear first, though, that these figures that you see here, we've got the times and the degrees and the altitude and the heading of the moon. You can do this with the sun as well here on timeanddate.com. This is the model. Yeah, a model is just tabulated data from which you can see a pattern or make predictions. So nothing changes as far as what we see in the sky, and all the figures that we're given here, it's really quite accurate. So there, it's very important to understand that no one disputes what we see happening in the sky. It is just that you have to understand that you can interpret that in many different ways, and create various different illustrations depending on what you assume to be at the center of your model, or what you assume to be driving the model, or what is moving or not moving in the model. And of course, we are told to assume that the Earth is another planet spinning around the sun in a heliocentric model. But understand that the numbers, the data, the observations is the model. And because we're talking about observations, what you have to take into consideration is, of course, perspective, which governs any observation you make. All right, so these are somewhat intangible measurements. They are accurate and predictable, and you can predict this for many decades or centuries ahead or in the past. Nothing changes, okay? And it's only this data that was available to the heliocentrists that was used to create the model. Assumptions were made, such as the Earth being another planet, and of course orbiting the sun, having the sun at the center, rather than, for example, a geocentric model with the Earth at the center. But regardless of what you decide to put at the center, or the shape or any movement you assume the Earth to have, these figures do not change. They are what they are, okay? But what we can see here, which is worth really thinking about, is we have, as you see here, on the 24th, the moon rising and reaching its zenith at about 2:40, 3 o'clock in the afternoon for me in Phuket. The moon has risen in the east, and it was setting in the west, fairly straightforwards there, okay? But what you can see is, if you consider this pyramid that we see in front of us here, okay, as a side-on view illustrating the observer's perspective. So for any given observer, at any location, they will be here in the middle. So imagine that is where I was stood when I was filming the moon, because it went overhead, okay? And we can see here that on the right-hand side there, we have under the time, we have an altitude of 83 degrees for the moon. So it was quite high up in the sky. The heading was north at 352, so almost directly north. So a few degrees off, going directly over my head at 90 degrees, because I am a little way from the equator. But what's happening, of course, at this time is the sun and the moon are making their way between the Tropic of Cancer and the Tropic of Capricorn, and crossing the equator as well, as we get this change in seasons, okay? Again, the fact that we have this change in seasons would really indicate some kind of intentional design, rather than a haphazard accident of a big bang ending up throwing us around the sun at incredible speeds. Okay, so what we see here is a side-on view of the observer's perspective, really, as the moon rises in the east and then goes overhead and off towards the horizon and sets in the west. When really what you can assume the moon or the sun doing are traveling in a straight line that is parallel to this surface here. But because of the observer's perspective, the sun or moon or whatever is coming towards the observer in the sky will rise up from the horizon and then go down towards the horizon in the opposite direction. All right, so that's what we were seeing from Phuket. So we'll look at this in Stellarium as well later on, but let's just first of all compare this to the observations made from if you were in Bristol in the UK. So here's the 24th, and you can see here that we have the moon rising east-northeast, but it only goes up to an altitude of 54 degrees for that observer. So, you know, the observer in the UK is looking in a southerly kind of direction and seeing the moon and the sun arc across the sky but not go directly overhead. Okay, so they're not directly under this. again, this is something that would point to everything being local, because there is this dramatic difference in the angle at which we observe things in the sky. If everything was really, really far away, then we'd all be looking at in the same direction, wouldn't we? But that's not how it occurs. This is real data. This is the model, and it works perfectly in terms of the way individual observers see the luminaries passing overhead or arcing across the sky, depending on where they are in relation to the equator, or where the sun and moon are located at any given time during the seasonal changes. All right, so does that help kind of put that into perspective, as it were? What we can do now, though, is have a look at the same situations and observations in stellarium. So what we'll start with here is my view in Phuket in the morning, on the morning of the 24th. Okay, so at the moment I'm facing east, I'm heading east, and you can see here this wonderful alignment of the sun, Mercury, Jupiter, the moon, and Venus coming up in the east. So this is the start of that day, and so I just wanted to move this forward to show you how we see this kind of tail following the sun. You can see here that it's going to go overhead. So we've got now midday. I'll just move the time forward a bit there to about 4 o'clock in the afternoon Phuket time. So obviously we'll just now turn around and face west, and we can see what I saw in the evening from Phuket. So now, of course, having gone overhead, this trail of Mercury, Jupiter, and the moon are following the sun. They now appear above the sun, whereas they were below the sun previously. And what we don't see here is Venus, because Venus was being occulted by the moon. So as time goes on here, very slowly, we see what I saw in Phuket, and that is the Venus eventually emerging from behind the moon. And here you can see Venus lighting up. It's a big light in this illustration, but that's showing you that Venus was blocked, and it's now becoming revealed as the moon was hitting the horizon. Okay, so it's pretty accurate of what we were seeing. And you can also see, hopefully, the smiley face moon here, the crescent of the moon. Now, whether you assume the moon is reflecting sunlight or not, that's entirely up to you, but it doesn't matter, again, whether you consider it, what kind of shape or movement of the earth you might consider going on. We can see that this smiley face is pointing at the sun here, and for me that's how it did actually appear, as you'll recall from the video footage just now. Okay, so there you go. We had Venus being blocked at around 6 o'clock or around that time here in Phuket. So now we've changed our location to be observing from Bristol in the UK. It's about 6 o'clock in the morning in the UK, and that makes it about 1 o'clock in Thailand. So down here on the right hand side is the Thailand time. So at 1 o'clock in the afternoon, the sun was pretty much at its zenith for me. So you know that by looking in this direction where the sun's rising, that you are looking at someone who is experiencing midday near the equator in Phuket, Thailand, southern Thailand. Okay, and as predicted, the sun will rise in the east and set in the west during this equinox period for people in almost any location on the earth. Again, that is the predictive nature of the model, but how you interpret what we see going on in the sky can be very different, and it doesn't have to be us being on a spinning globe. So there's no contradiction with anything. We see what we see, and as we move time forwards here, you can see that the Sun, Mercury and Jupiter and the Moon and Venus appear in a very different fashion from this location. Remember, for me in Phuket, they were rising almost vertically from the eastern horizon because they were going to go overhead. So you can look at this and see that if the Sun and the luminaries are doing concentric circles above a level Earth, expanding and contracting to create the seasons on the Earth, we are outside of this circle. We are north of this circle of the Sun as it goes across the sky, and so of course it only arcs across the sky for us. It doesn't get to a very high altitude. It's not going overhead. So if you consider these luminaries to be maybe a few hundred or a few thousand miles away, following some kind of path in the sky that takes them around and above a level Earth, you can see that we're just looking at this section of this circuit, just like you would see race cars going around a circuit. As they got close to you, they would be higher, and as they get further away, they would appear lower in the sky. Okay, this is like, as we saw in timeanddate.com, this perspective view from a distance that's not directly under these local luminaries gives us this arc, because we're outside of that circle. Now, I'm not saying that is how it is. What I'm saying is that you can perceive it in many different ways, and the observations don't change. Nothing changes about what we see, but what does change is our perception of what we see going on in the sky, depending on whether you have any presuppositions in the first place. So again, there's no denying that we can predict these things happening. And let's just move over to face the west here, and we'll do a little comparison as well. Oh, I should also just quickly show the period. If we go back a bit, sorry, we'll show the time when, let's go back now. You can, so I'm just going to go back to the time when Venus was occulted. Okay, so here you can see in the sky it's 6 o'clock in the evening in Phuket, and you can see here in our view from the UK looking south. Now remember, for me, because these luminaries have now gone much further away from me, remember my midday was over here. Okay, now for me in Phuket, I was seeing the moon approaching the horizon, and Venus was just starting to poke out from behind the moon at around, there we go, at around 8 o'clock in the evening. Okay, so it's 8 o'clock in the evening Phuket time, and for me over here way down southeast, I saw the moon almost on the horizon. I think it was about 13 to 18 degrees altitude, I'm not sure, and Venus starting to appear from behind the moon. But the difference here is that you have, I had a kind of smiley face, and here you can see it's almost flipped 90 degrees to have this, have it on the side, this crescent on the side here. But again, there's no contest with the way this is shown. But how close or far away those luminaries are is of course something that you can't actually ever prove, but what you can measure is the times and the locations that they will come up. Okay, so it's easy to understand that we are seeing this from a distance that takes us away from that arc that we had in Phuket. So let's go back to this now. Here's our evening view. All right, so you can see that off they go into the distance. But if we go back to this view, we can see from Phuket this line is almost vertical, but slightly off to the right there. Go back to how it appeared in the UK. All right, so you can see that we're outside. We're to the right of all this. We're not directly under it. And this kind of dispels the illusion that light is traveling to us in parallel lines. So even though we can see the sun rise and set and all these other luminaries rise and set in predictable locations at predictable times, the actual view that we have when we take perspective into consideration is very different. That's not really accounted for. Okay, so one last thing I'm going to do is to go through what some writing about Zetetic Astronomy says about how we can perceive these lights in the sky from any given location. So let's now complete the picture, as it were, of this level Earth with a model made on the laws of perspective and the way we see the luminaries behaving in the sky from this book, Zetetic Astronomy, Earth Not a Globe. You might have heard of this before because it's been made well known in recent times by Eric Dubé, and we're going to look at just a couple of passages here that illustrate how, again, nothing changes. The model, as it were, is the data that we collect, the observations that we make, and the predictions that we can make from these observations and collecting this data. So nothing changes in that respect, apart from an understanding that we are incorporating perspective, the laws of perspective, into the observations that we make. So it's not only an assumption that it's on a level Earth. There's a lot of information in this book talking about how it is ascertained that the Earth is indeed level and it's stationary. That is all explained. So I'll leave a link to this book in the description, but we'll just jump to the section that we're concerned about. Okay, and that's about the assumed distance to the sun and the stars, or as it says here, the true distance. Again, I'm not advocating this as the model for the flat Earth. This isn't the only alternative that you can consider, but it is definitely an alternative that makes sense as far as we can make sense of it. Based on our real-world experience, real-world science and physics, and real-world mathematics. Okay, but it's not. I'm not saying that you have to believe in this model, but you can at least try to detach yourself from the globe model and take this one into consideration as a way of starting your own journey of self-exploration if you want. You can come up with other conclusions if you like, but this is at least an alternative that appears to make sense as far as we can tell. So I won't read all of this, but it just shows you here a very simple trigonomic calculation or measurement that you can make. You have a ground point for the sun directly under the sun, and the height to that sun will be an equal distance across the surface, and when you have an angle of about 45 degrees here, this is when you get the same distance, and it turns out by these calculations to be about 4,000 miles. And this is cited again here, about 4,000 miles, based on various readings that were done from official sources. Okay, so I think, yes, and just here it says that you can then consider the other stars as being about 6,000 miles away. And really, this makes much more sense than assuming that the sun is 93 million miles away and many, many times greater in size than the Earth. In this case, we consider the sun as being very local and casting a local light, so it's much, much smaller than the Earth. So this is again important to consider when you are trying to adapt your mind to contemplate different so-called models, is that you have to detach from all those explanations and assumptions made for the heliocentric model. The sun becomes smaller and closer, and so does everything else, and the Earth becomes, of course, level and stationary. And so that being said, we can now just look at what it says about the sun moving in a circle over the Earth, concentric with the North Pole. So basically, it's a circle or an orbit of the sun above the level Earth that's going to expand and contract, giving us the seasons. Okay, so we'll just read this quickly. As the Earth has been shown to be fixed, the motion of the sun is a visible reality, and if it be observed from any northern latitude, so anywhere north of the equator, and for any period before and after the time of southing, so that's during this time as the sun is getting closer during the summer months, or passing the meridian, which is what it's doing now during the equinox, it will be seen to describe an arc of a circle. An object moving in an arc cannot return to the center of such arc without having completed a circle. This is, again, common sense. We saw, as in stellariums, the sun's path seen from Bristol in the UK, that we are watching the arc of a circle, a section of a circle, and naturally the sun will have to come round again to complete that circle. The Earth rotating won't necessarily make that happen. All right, so this the sun does visibly and daily. To place the matter beyond doubt, the observation of the Arctic navigators may be referred to. Captain Parry and several of his officers on ascending high land in the vicinity of the North Pole repeatedly saw for 24 hours together the sun describing a circle upon the southern horizon. So if you can consider these people almost at the North Pole, they basically watch the sun go around 360 degrees, never quite setting. So this would be a time when we have quite a tight circle around the North Pole. And so, yes, people at a high elevation may well not see the sun set while it is doing this smaller circle above the level Earth. So moving on to section 5, here it describes the diameter of the sun's path as being constantly changing, diminishing from December the 21st to June, making a smaller circle, and enlarging from June to December. So basically, if you're in the northern region closer to the North Pole, then as that circle of the sun orbiting above a level Earth decreases, then of course it will get warmer for you. And then as that circle gets larger, then it will get colder for you. Now, again, it's worth pointing out that you can consider the North Pole at the center, or you can consider the South Pole at the center. It doesn't make any difference to the observations that we make. Just now, when we were looking in Stellarium, I asked you to consider that we were looking at the sun doing a circle from the outside of that circular path, and that would in fact put the South Pole at the center if we were imagining ourselves being on the outside of this circle. But you can also switch it around and consider it from this point of view, where we have the North Pole at the center, and so if you're in the northern hemisphere, you are on the inside of that circle that the sun is making. But the effects of perspective would be the same, because even though you're looking at from the inside of a circle, it's only when the sun comes close to you that it will come into your vision and appear to rise above the horizon. And that's what you can see in these figures here, where the sun's altitude is 62 degrees at the height of summer, so it's quite high in the sky. Again, you could be looking at this from the outside of that circle, or you could be looking at it from the inside of that circle. It would appear the same. So this doesn't dictate that the North Pole is at the center. You could put the South Pole at the center if you want, and we'd still be looking at the same results or data that we've collected from real life observations. How we interpret that is again down to a matter of interpretation. So as you can see, that as we go through the months getting towards the autumn and the winter here, the altitude of the sun decreases. So we can basically say that it's getting further away. It's in this model assumed to be a circle that's getting wider and wider, taking the sun away from us and going down to about 15 degrees there in December, and then rising again slowly as the days get warmer through April, 48 degrees, May, 57 degrees, and back up to 60 degrees around that time. Okay, so again, this is the model. That's all the model is. You can make these recordings and you'll get the same results from that particular location. It's very predictable in that sense, but you can interpret it in a myriad of ways. So this particular interpretation, as you can see here, shows this circle here, A, with the sun's path, okay, going around that way and casting a local light, and it's a fairly tight circle during this time. Okay, so if we then go down, we won't worry about the explanation here, but we'll just show as a comparison. Circle A here and B shows the difference in these the width of these circles, or the diameter of these circles, and these are basically between the Tropic of Cancer and Capricorn, and it's at this time of year now, during the equinox, the vernal or spring equinox, that the sun is passing what's referred to as the meridian, between the midway point between Capricorn and Cancer tropics. Again, it all fits fine on this top-down flat Earth map. And as viewed, if you're in one of these particular locations, the altitude of the sun will depend on whether that sun is doing a tight circle with a small diameter or a large diameter, and giving us the seasons in any given location. So please do go and have a look at the rest of this, look at the details, and you'll see for yourself that it's all put together from real life observations, but it just takes into consideration the fact that any observation is governed by perspective. And that, my friends, is the imaginary curve. Thank you very much.